Hello student, welcome to Vidyanest. We are doing relation and function. Today we will conclude. See, relation function, different type of function we have already discussed. Now we will have the concept of domain and range. Domain and range and codomain. When I persuaded relation, then one superficial idea I had given what is domain. Today we will go through the depth of it. See, if there is a set A, set B. Set B contains 3 elements, suppose, and set A contains, and function maps from A to B. Function maps from A to B. So x1 will have image fx1 in B, x2 will have image fx2 in B, x3 will have image fx3 in B. Okay, so the set formed by the images whose pre-image belong to the set A is called range. Set A is the set of defined elements that are called objects. Set B is what? Set of images. But the object which are selected from A have some image in B. So those images whose corresponding pre-images are belong to set A. Okay, so those images whose corresponding pre-images belong to set A will form range, and the whole set, that is set of all type of images, that is called codomain. Codomain. And here it is clearly visible that range is the subset of codomain. Range is the subset of codomain. Now, in domain, elements will be defined, well defined. Okay, those elements which have the presence, abstract presence in the world, cannot form domain. Abstract or virtual. But if these objects are well defined, then these objects will form domain.
Okay.
And understand?
Yes, sir.
Like suppose fx are denoted by x square, where fx are defined by x square, where f maps from real number to real number. Maps from real number, domain is real, range is also real. The means codomain. So you choose 3 real number in set A. Say 1, 2, 3. So if I put 1 against 1, I will get 1 square. Against 2, I will get 2 square. Against 3, I will get 3 square. So this set A, 1, 2, 3, that is domain. And the set formed by means real number but in square form, that is range. And here it is clearly visible this set is the subset of B because it is defined that codomain B is also real. So barring these elements, barring this real number, there are other real numbers exist. So clearly visible range is the subset of codomain. Here it is real. So this is the basic definition of domain and range. Now let us take few simple example to comprehend what is domain and what is range. See, suppose you have got fx is equal to root x minus 1, where f maps from real number to real number. Find its domain and range. Find its domain and range. See, I have told you in domain the elements, objects must be defined. So when this function will be defined, if the variable or any term is kept under root, if it is greater than or equal to 0, then it will be defined. Otherwise, it is imaginary, complex number.
Yes, sir.
Yes. So to be defined, this x minus 1 must be greater than equal to 0. So x greater than equal to 1. So domain of definition starts from 1 and goes to infinity. So domain is what? How to write it symbolically? 1 to infinity. Or you can write x belongs to 1 to infinity. Now what is the in this domain? What is depicted? Minimum value of x. Minimum value of x is 1. So you choose that 1 and put here. If you put 1 minus 1 will be 0. So range, that is y. If I put 1, it will be 1 minus 1, 0. Now keep on adding the value. Put 2, root 2 minus 1, then it will be 1. Then put 3, 3 minus 1, root 2, and so on. So range y, it is being started with 0 and ends with infinity. So this is the way you can find domain and range. Let us take another example. Fx is equal to mod x, where f is defined from or maps from real number to real number. See, you know the graphical presentation of mod that was taught in the last day, that V-shaped. So for all real value of x, that V-shaped will persist. Therefore, domain will be all real value. But what about range? If you see, the line is approaching origin, and at origin it bumped and got reflected at this point of symmetry. So y, the value of y cannot go below x-axis. It will remain upwards always in above x-axis. So range will be, it's C, when this line meets x-axis at this point, y will be 0. The line bumped at this point and returned back. So it will go infinitely. So this is range. Understood?
Yes, sir.
Now, another type, suppose you have got these are, board level, very simple example. For simplicity, okay, we'll start and reach the highest level, JE level. See, fx is this. Now, its domain, find its domain. See, function will be undefined when? If you get 0 in the denominator, yes or no?
Yes,
So,
sir.
yes, function will be undefined if x square minus 6x plus 8 is equal to 0. That means x minus 4 into x minus 2 is equal to 0. So x is equal to 4 and 2. So at these 2 points, function will not be defined. So when it will be defined, therefore, function defined in all real number excluding that 2 and 4. So that is the domain. Hope you could follow.
Okay, sir.
Now, suppose you have got root over of x square minus 4x plus 3 and function maps from real number to real number. Find its domain and range. See, function will be defined if the term is kept under root is greater than or equal to 0. So, function will be defined if x square minus 4x plus 3 greater than equal to 0, because under root negative in real number will not exist. So, if I factorize it, I will get now how to find the domain? We'll use wavy curve method. What is that wavy curve method? You put 0, you put 0 against x minus 1 and x minus 3. You will get 2 points, x1 and 3. Plot it on number line. Now you choose any value between 1 and 3. Suppose I am choosing 2. Now you put here 2 minus 1 is positive, but 2 minus 3 is negative. Positive into negative, negative. So if I choose any point between 1 and 3, any point between 1 and 3, this condition will not stand, will not satisfy it. So there is no such value between 1 and 3. Then you choose one value which is greater than 3, suppose 4. You put here 4 minus 1 is 3. 4 minus 3 is 1, positive. So 3 onwards, the function is defined. Choose 1.0. 0 minus 1, minus 1. Minus 1 into minus 3, 3, positive. So between 0 and between infinity and 1, any value if I choose and put, that condition will be satisfied. So what is domain? Minus infinity to 1 and 3 to infinity. 3 to infinity. This is the domain.
Okay, sir.
Here why I have put semi-closed interval? Because semi-closed means where the closure bracket is given, that means that element will be included. Can I include 3? Let's see, put here 9 minus 12 plus 3, 0. 0 under root is valid. Can I include 1? 1 plus 3, 4. 4 minus 4, 0. I can include 1. Got it?
Yes, I got it.
So this is the domain. How to find range? So this thing, I will equate this thing with y. Let y is equal to root of x square minus 4x plus 3. Square it. Then is equal to 0. So what form is attended here? Very known form of quadratic. X square plus bx plus c. And you know, once you get a quadratic of this type, then how to solve? That Siddhacharya's rule, which you are
Yes.
taught in your junior class. See, what is that rule? Here, 3 minus y square will be considered as c. Minus 4 will be considered as b. And 1 is considered as a. So what will be x? Minus b. So minus of minus 4 plus minus b square minus 4a C by 2A. Once you get this, you will get what? 16. Remove the inner brackets. 12. Four y square by 4. Now what is this simplified version? Then we will get x will be, you take 4 common, that will come in terms of 2, and that 2 will be taken common. So this simplified version is this. Now you observe from which set to which set the function is being mapped. Real number to real number. Here domain is real. That means x is real. When x will be real? If the discriminant, this is the discriminant part, discriminant is greater than or equal to 0.
0.
That you are taught in quadratic equation in class 9 or 10.
Yes, sir.
So you write as x is real, therefore discriminant y square plus 1 greater than equal to 0. Now you have got y square plus 1 discriminant, this is discriminant, greater than equal to 0. For what value of y it will be possible? Any value according to your wish you can put in place of y. Always it will be greater than 0 because y's power is 2, even number. If you put plus or minus, whatever be, it will be plus, and that will get added with 1. It is automatic. Automatically it will be greater than equal to 0. So what is the value of y to be chosen? All real values. So y must be all real values. Therefore range all real values. Okay, so what is domain? This thing is domain and this thing is range. Hope you could follow.
Yes, sir.
See, in function, you are supposed to be taught logarithmic function. In few board, ICSE board or any state board, you are taught log in school level. See, suppose you have got a to the power x is equal to z. In finding domain and range, logarithmic function will have an important role mainly in competitive level exam. Log function, logarithmic function. This is, exponent. You are taught in junior class. A to the power x is equal to z. Then how to express the power? Power will be expressed by the operator log. Log of z to the base a. Log of z to the base a. Suppose you have got 5 square is equal to 25. How to express that? 2 log of 25 to the base 5. Now, always remember, in log, few things to be followed. What? See, few standard formulas are there. Derivation not needed now. See, it was taught in junior class. Suppose log z to the base a plus log z1 to the base a. If you get the composition of two logarithmic function in this way with plus sign, what will be the result? Z1 to the base a. Log of z to the base a minus log of z1 to the base a. Log of z by z1 to the base a. Now, if always remember that if base is not mentioned, then for algebra, you can take base as 10, and for calculus, you can take the base by default E. E stands for exponential. Now, see, if you get A C log z to the base a, what I will do with this C? C will go to the power of z. If I get always remember log a to the base a, always 1. Log a to the base a, always 1. Log b to the base a means log b to the base 10, log a to the base 10, or E. If you wish, you can keep 10 as silent. Now, log b to the base a into log a to the base b, always 1. Now, few things to be remembered, that a to the power x is z. So, these formulas to be remembered in log, and there must be some relation between exponent and base. What is that? See, a to the power x z, this z cannot be negative. Whatever value you put, suppose instead of a you are putting, this a cannot be 0. In your junior class, you are taught this a cannot be 0. 0 to the power x will not be defined in this way, cannot be defined. So base in log, base a cannot be 0. If you put minus sign in place of a, you will get oscillatory function, oscillation between plus to minus. You see, suppose I am putting minus 2 to the power x. If I put 1, it will be minus 2. If I put 2, it will be plus 4. If I put 3, it will be minus 8. If I put 4, it will be 16. So, it will oscillate between plus and minus. Okay? So, it cannot converts to a finite limit. So, that base A cannot be negative. Cannot be negative. Now, whatever be the value, barring this value a equal to 0, whatever be the value of a and the power x, it cannot be negative. Suppose minus 5 to the power minus 2, both are negative, but result, see, 1 by minus 5 whole square. So 1 by 25 positive. So z cannot be negative. The z cannot be negative, and z cannot be 0 also. Whatever be the value of a and x, it cannot be 0. So these things must be remembered in finding domain and range involving log. Understand? See, another thing, if you wish, you can derive by your own. What? Suppose you have got a log like this, half and 1/3. Base and exponent both are proper fraction. In this case, what will be the sign of this? See, log b to the base a. Log b by log a we know. So log half by log 1/3. Now, see here I have not written the base, means base is silent. If you wish, you can write here log 2 to the power minus 1 by log 3 to the power minus 1. According to this rule, whatever be the power of exponent, it will be brought out. This minus 1 will be brought out. Here also this will be brought out. Cancel. Whatever you have got, that is greater than 0. So, from here, one conclusion I can draw. What conclusion? What conclusion? That in this Z and A, if Z is a proper fraction and A is also a proper fraction, then log Z to the base A must be positive. Okay, it must be positive. But see, if Z is a improper fraction, Z is improper fraction, but A is proper fraction, then log Z to the base A negative. You can judge by your own. How? Suppose log 3 by 2 to the base half. That means log 3 by 2 by log half. It means log Z by Z1, log Z minus log Z1. Base is silent. So I can write log 3 minus log 2, log 1 minus log 2. It is positive. It is negative because log 1 is 0. So resultant will be negative. So this supports this result. If you reverse it, means if what is the reverse? If Z is proper fraction and A is improper fraction, then also log Z to the base A greater than 0. Always remember that base A, earlier we got, cannot be negative, cannot be 0, cannot be 1 also. Okay? So these are the, just overall idea of log, and you will get so many sums in JEE in the yesteryears which had involved log, and you are told to find its domain. See, one sum of that type will do. Hope you could follow this.
Yes, sir.
See, find the domain of the function fx is equal to root over of log base half exponent, you are told to find the domain of this function. How to find? See, one thing we have understood, that whatever be kept under root, it must be greater than or equal to 0. Otherwise, the function will become undefined. Now, when here you have seen the base is half, and few minutes back we have discussed this property, log z to the base a greater than 0. If that condition is satisfied, mean base is proper fraction and the exponent z is also proper fraction, then it must be greater than 0. So here in place of a we have half, and here in place of z we have 5x minus a square by 4. Here this a, that is half, lies between 0 and 1. So to be defined, why to be defined? Because this thing must be greater than 0. So to be defined, according to the log we have just discussed, to be defined, this 5x minus a square by 4 also lies between 0 to 1, obeying this rule. Okay? Because log of something with some base must be greater than 0 if both base and exponent are proper fraction. Here base is proper fraction means exponent must be proper fraction. So it must lie between 0 to 1. Now, step by step, we will find the interval in which x lies, and that interval will be considered as domain. You observe, if I choose this inequation 5x minus a square by 4 less than 1, then 5x minus a square less than 4, then you keep all the terms in one side and 0 in other side. How? By keep 0 in left hand side, other terms x square minus 5x plus 4 in right hand side. Now, in other way you can write 0 less than this means this thing is greater than 0. Now, can we factorize it? Yes. After this stage, I am writing here, asterisk sign you follow, x square minus 5x plus 4 greater than 0. What does it mean? And once you get this type of inequation with factor form, then you use wavy curve method. Means in number line you plot 1, that x, if you make this thing equal to 0 and that thing equal to 0, you will get 2 points, 1 and 4. Now the question is that chosen value of x, will that lie in between 1 and 4 and anywhere out of that region? See, to examine that, you choose any arbitrary value between 1 and 4, say 2, and put here 2 minus 1 will be 1, 2 minus 4 will be minus 2, 1 to minus 2, negative but given positive. See, so there is no such x for which this condition satisfied if it lies between 1 and 4. So x lies where? Away from 4 on left hand side of 1. That is one condition. Now there is another inequation which cannot be ignored, this thing. Few minutes back I had taken this thing, now this thing. 0 less than 5x minus x square by 4. What I will do with this 4? 4 will be multiplied by 0 and get cancelled. So in other way I can write 0 less than this means you bring this part in left hand side, x square minus 5x less than 0. Take x common, x minus 5. Now again way become method. You see, if you put this, make it equal to 0, x will be 0. If you make it equal to 0, x is 5. So there is 0, there is 5. See, you put any value lies between 0 and 5, say 3. Does it satisfy this condition? 3 into 3 minus 5 minus 2, multiply minus 6, minus 6 is less than 0, condition is satisfied, so I can take one value between 0 and 5. So once you draw this interval, so we have got a common region. So that common region is the required domain, 0 to 1, 4 to 5. But that is not all. Now what this question will come, that what bracket should I put? Close bracket or open bracket? Close bracket means, will this 4 be included or not? 5 be included or not? 0 will be included or not? See, if you include 0 in place of x, if you put, then log of 0 undefined. I told you that z cannot be 0. So 0 will be excluded. Can I put 1? See, 5 into 1, 5. 5 minus 1 square is 1, 4. 4 by 4, 1. Log 1 to the base half, 0. Yes, that is valid. I can include. Can I include 4? 5 into 4. 20 minus 4 square, 16. 20 minus 16, 4 by 4, 1. Yes, log 1, 0, under root 0 is valid. Can I put 5? 5 into, no, I will get 0. So this is the domain. Got it?
Yes, sir. Got it.